Ok, we are live. Pessoal, antes da gente começar essa live, eu vou fazer aqui uma pequena introdução. Agradecer vocês aí que vão estar chegando aí com a gente, nós vamos guardar uns minutinhos. Essa live vai ser em inglês. Eu vou fazer aqui apenas um welcome em português para vocês. E dizer que essa semana de esquenta, né, como parte da semana do Agilista Raiz, que vai acontecer na próxima semana, a partir do dia 1º de fevereiro. E hoje eu tenho o prazer de ter aqui os meus mestres para discutir com a gente um pouco sobre Agilidade Raiz. E a gente vai interagir com vocês. Então, eu vou poder ver os seus comentários. Já estou vendo alguns comentários aqui, pessoal, do Roberto. Obrigado, Roberto, da Rosa, estamos aí, Arthur, Frederico, Jack. Então, simbora. All right, guys. So, just did my welcome part. First of all, Mary and Tom, I would like to thank you for accepting the invitation to be here. I'm really honored for this opportunity. And once again, I'd like to express my gratitude and appreciation for all the things you have done to our industry. I think that, what you did is very bold. It helped transform people and organizations. And for me, as you know, it's your first book was the first book about Lean and Agile that I read back in 2003. So it's 20 years ago. It's a long time already.
There you go.
Yeah. And I could say that I am very lucky to have you as my mentors and have had the opportunity, to meet you in person and to bring you to Brazil 3 times. I still remember today our trip to the mountains. I hope you enjoyed that.
Oh, yes.
This. So the idea here today is to discuss about the concept of what I call the root agility. And I will provide just a little bit of context, and then I will ask you some questions, and we'll probably have some questions coming from the audience as well. But the thing is, when we started, like 20 years ago, basically we didn't have any Scrum Masters around. We didn't have Agile coaches, but we still did, let's say, a very good version of Agile. And in my opinion, in my experience, the Lean principles or the Agile methods are just like a way to implement the Lean principles. And most of them, of course, that I have learned with you guys. And I remember that we have grown in that kind of context where everybody used to embody the Lean principles and values. And regardless of our functions, like I could be an executive or a developer or an engineer, we ourselves would be the agilists. We would be the ones responsible to improve the process and deliver the products. And from then on, we saw several waves of agility. Some of them I like concerns with technical debt management and other stuff. But then we had some things related to scaling agility, getting agility to the business or business agility and other stuff. And more recently, what I have seen, and especially here in Brazil, is that the sense of the agilist is not embodied by everybody anymore, and it's like being outsourced to a person. And this person is not an Agile coach, and it's not a Scrum Master. It's like a mix between them. And sometimes they don't even have the ability to put things to work, because it seems to me that agility has fallen into a place where people think that agility is just about Scrum and Kanban. And they forget about the business, they forget about value generation, they forget about engineering. And for me, engineering has a big role in having agility when we are talking about software development. And of course, strategy management, the management of the business strategy is also very important. So to start our conversation here, I would like to hear from you. What do you think about this movement? What do you think about this that is happening
Okay.
with the context?
So I would like to start backwards with a bit of history. You said something that really triggered me. You said 20 years ago, we didn't have Scrum or Scrum Masters or anything like that. And you know what? 20 years ago, I had been coding, programming software. My first job was in 1967. Okay, 77,
I
87.
was not born yet.
Right. So 30, I had already been doing software for 30 some years, over 30 years, without any of the agile methods or techniques. And I'd like to believe that I was very good and that we were very good and we did some very impressive things. And the first stuff I did was at a university for a professor. And we were working in assembly language on computers that he had gotten for free because the company went bankrupt. Some of the first mini computers. And we programmed them to do physics experiments. And let me tell you, none of us would, we just had to figure out how to solve the problems that were to control the equipment that was scanning bubble chamber film for high energy physics. And then I worked at Bell Telephone Laboratories. And I worked at Bell Telephone Laboratories because at Bell Telephone Laboratories, and that was my first job. That was in 1967, just even before I worked at the university. And at that particular place, we were programming a telephone switching system called the number 2 ESS switching system. And we were programming to mimic the very sophisticated electromechanical switching systems that already existed in electronics. And we were trying to make sure that we had the same kind of reliability and cost structure as the electromechanical stuff. And because of that, we were programming a computer which had complete duplication and checking to make sure if anything went wrong, the bad computer got tossed out and then the bad part was figured out and then the new card was put in. And that's because we were working not with integrated circuits of any kind, but with individual circuits, which had lots of them, mean time between failure. And people who built electromechanical systems understood that stuff would fail. So we had to figure out how to do that. It took some years to figure out how to get a reliable computer to switch telephone systems. And then the next thing that I observed is that there were people that were starting to do computing to replace a lot of manual labor. So, for example, when I was a kid, I took a paper book to the bank. And if I had some money to put in the bank, I gave them my book. And they wrote in the additional money. It was all manual, no computers. So you can imagine that all of that manual work that used to be done by clerks was now starting to be done by computers. And a huge amount of infrastructure built up around automating manual tasks. And in order to do that, you had to understand the manual process. At the same time, or maybe just a little bit later, engineers started using computers to speed up what they were doing, just like my boss at the university who was trying to speed up physics experiments. Other people were trying to speed up things. And so then my next job after the university was to come to 3M, where the engineering department was trying to figure out how to use computers to do much better job of controlling very big process equipment, huge, dangerous, explosive equipment. And how do you put electronics in an explosive environment? And how do you make sure that if the computer goes off, because it's going to fail. I mean, that was
Right.
Any engineer building process equipment that could kill people and it could explode knew that every so often the electricity will go down and everything will disappear. And if you haven't built a fail-safe process that will shut itself down when it detects a situation like that, you're going to kill people. So we had to program into our software the same kind of concerns that the engineers programmed into the electromechanical control systems. So we devolved into two different paths for computing. One was to automate these manual processes, and one was to add in an electrical engineering department, add more capability to the systems that were now that used to be done with electromechanical systems. I mean, we had massive telephone switching systems before there were computers. But we changed to computers because we could do even more. We had very good ways of controlling steel mills and rolling steel and stuff like that before there were computers. But we needed to start automating them even better and more sophisticated ways, and therefore we added computers to that environment. But the two types of programming went two different paths, okay? One path was the engineers using computers to help control equipment, and one path was in the company where there was a department called IT, or information technology, that was trying to automate manual stuff. I was not in an IT department, ever. I was always programming equipment control stuff. And I learned how to do that mostly in engineering departments, because the engineers were the ones who built the systems in the first place. And okay, so then we did lots of other stuff, and time passes, and along comes 2000. The year 2000 is people started talking about this thing called Scrum. And
agility.
And they talked about,
it's reprogramming and all this stuff.
Same time, Agile was there. Scrum was an instance of Agile, but they equated it to a process, because a methodology. Well, that's fine if you're in a department, in an information technology department inside of a big business, trying to automate existing processes. But that's not the way engineers think about solving problems. Engineers think about the problem, understanding the problem, what tools they can take to apply the problem, how they would do that. And generally speaking, engineers are trained by more senior engineers. And when you have people who, let's just say there's an earthquake, there's earthquakes all the time. Structural engineers are going to go in and they're going to evaluate the soundness of building structures throughout the whole city if there's an earthquake. Now, those structural engineers are led by more senior structural engineers who've been there, who understand the kinds of details you have to know how to do in order to, do structural evaluation and make recommendations. They're not told by their customers the answer to come up with. They're not told how long they have to do the job. They're told, figure out what's wrong and tell us what we need to do to fix the building. So what's happened is we've sort of split into these two paths, where some people think about software as like a problem-solving engineering approach, especially those who've used it in an engineering environment like myself. And some people think about it as another process to automate. And when you think about it as another process to automate, you write down the steps and you say, people do this and do this and do this. And here's somebody that makes sure you're going to do that. And that's interesting, but it does not address all of software. And for sure anymore, what we've done recently is we've taken software, and not only do we put it now in equipment control, we put it everywhere. It's running this system, this session of ours. It's running our cars. Our cars are computers on wheels. It's in all products. And when you put computers not to automate business processes like keeping track of money, but you put computers inside of pieces of products, then you have to think much more like an engineer than think like somebody who's following a standard process. It's not like there aren't processes in engineering, but they're just built into the way that the senior engineers do things. So of course we always did fail-safe. But what is fail-safe? Depends on the environment. Fail-safe in a manufacturing plant is a lot different than fail-safe in a driving vehicle. So you have to do these things so that when things fail, that you can't crash the airplane if only one thing is wrong, because maybe it's, there's an error. So you learn all this stuff and you take a problem-solving approach to understanding the problem and dealing with it. And in that environment, the kinds of things that have evolved into being called Agile really don't work. Having someone that leads, here's the process, here's the things that you're doing, but don't ask me any questions about, the technical details, because that's not my job to know. I never had, when I was doing process control systems, a boss or my boss's boss who didn't deeply understand control engineering.
So let me get that part for to increment on that. So as I understood, you were developing software that if failed, it could blow up the work environment. So that's a very dangerous situation. And I think probably, well, most of people that I know nowadays, they don't develop software that involves life-threatening events like this, or, maybe financial threatening events. But the thing that I think it's important here is this idea that when we develop something, we need to be fail-safe, right? If we are going to fail, we need to not to get hurt. We need not to crash everything. I really like that. And on the other hand, you said something about that the engineers, they will come up with the solution to a specific problem, right? And I don't want to be rude and not to put everybody on the same bag, but and again, we have some exceptions, but most of software developers that I see nowadays, they are order takers. It seems that they don't think anymore. They just get a card with something written on it, and they write the code for that one, but sometimes not even understanding what's the value behind that piece of software that they are building.
Well, that's the unfortunate after effect of everybody deciding that Agile is the way to go.
Yeah, and then that I think it can connect to a question of Lavoisier, which is here with us, who's here with us. Would you use the term software engineering, or do what do you think about that? Do you think we could
definitely
call developers like software engineers?
Well, I like to think of developers as engineers and be called software engineers, although there can be an argument over it, because I have to tell you a story. When the airplanes crashed, and they found out that Boeing had people writing software, and the software would go ahead and dive the airplane down with only one failure point.
The NCAS
my son,
system,
who
right?
is a professional engineer in civil engineering, called me and said, "How can you possibly call software people who write code engineers if they don't accept responsibility for knowing the effects of their code and making sure that it's safe?"
Mm-hmm.
And so I would like to think of software as engineers, and I would like to think of the people who write code as being very smart. I mean, I don't see how you can write code without being capable and intelligent and able to think for yourself. So why just narrow your vision to writing code and put blinders on for why you're writing it? In engineering, you can't do that, because you are responsible for the impact of the stuff that you design and put in the market. And if it fails, then you are responsible. So if a software person is willing to accept responsibility for what they do, then I would definitely call them engineers. And to me, that's the fun job, engineering. Doing what somebody else tells me, being an order taker, that's never been me. And I can't imagine that really capable people like that kind of a role. Maybe some do, and that's fine.
Yeah.
but for engineers, you are not order takers. You are responsible to understand what you're coding, why you're coding it, and you are responsible for the results.
Responsibility is the key thing here. A real engineer will accept and be eager to accept responsibility for the results of the work that they do. The order takers, well, somebody decided what they wanted. It's their problem whether it's a good thing or not. It's the consequences of your actions that matter. The work today is seldom done by one person working alone. It is usually done by a small team or a collection of small teams collaborating.
Mm-hmm.
But they have to have people who accept responsibility for the work.
Right.
They have to have a responsible engineer for each piece of the work and for the overall work. And each person on each team has to feel responsible to the people who are impacted by the final result. They have to be able to be proud of what they've done and know how what they've done contributes to the end result.
Yes,
Yeah.
we were always keenly aware of the fact that the safety of the people and the plant itself were our responsibility, even if we were junior people on the team. Unfortunately, in the IT departments, even at the same time, it was do what you're told. You don't have to understand the process you're automating. Just do what somebody else tells you.
Yeah, and that's the point, because that is actually what bothers me, because let me share some more context why I'm calling this, why I'm trying to rescue the concept of real agility, because when I read your first book back in 2003, I was in the middle of the chaos. I was working on a financial organization. We developed software for banking, and one of our systems once it was a payment system, and we used to integrate big payers like Coca-Cola, for example, with their banks to pay their providers, their supply chain providers. And so it was a big thing. And I remember once when we got one single bill that was not paid through our system because of an error in a date manipulation. So we were not manipulating dates. We were writing software using C language, and we didn't deal well with dates by that time. We used to have like timestamps to represent the dates. But in Brazil, and I think in the US, you also have that. Now we don't have anymore, actually, but we used to have daylight saving times. So one year, when we changed it to daylight saving times, we advanced 1 hour in the clock. And because of that, our bill was not paid because we used to have the midnight timestamp of the day. So that made a bill of 5 million reals not to be paid. And 1 day of the fee we got there was enough to pay the salaries of everybody in the team. So, and if the company was not strong enough, it would go bankrupt. Like if it was a startup without any sponsorship, it would go bankrupt. And we lived, I used to work overnights almost every day, and on the weekends it was very heavy environment. We were suffering pressure from the managers to deliver. We were unable to talk to the customers. On the other hand, it was very hard to keep the quality of our deliverables because we didn't have any engineering practices such as test automation, continuous delivery, continuous integration, or even a refactor. We would have to discuss with the manager if we could refactor the code to improve or not. So it was very hard context. And when I met Agile, I could say, in Lean, because the first book that I really read was yours, the Lean and Agile Toolkit. And then that brought me really a toolkit. I mean, a lot of practices and principles that helped me to overcome that situation. And also the extreme programming that was very high by that time.
Yes.
So we put together test automation, we put together a continuous delivery, a database migration, and then we organized the flow. We got visual management to understand our bottlenecks and so on. And that basically helped us to multiply by 4 our productivity and also reduce a lot escape defects to the customers.
Cool.
And because of that experience, and again, we didn't have somebody telling us what we should do or how we should do. We were figuring out by ourselves as a team what
Yes.
practices are good and what are not. And then fast forward in 20 years, what we have today, I still have seen people, especially as you said in the big IT departments of big corporations, and I've passed through some of them, fortunately, in the last 5 to 7 years, working with transformation projects. And And by running value stream maps to understand where the demands would start and what they would finish, I realized that most of these organizations, they are taking 12 months to deliver solutions to the business. And when we look to the efficiency of that process, we see about 3 to 5% of efficiency. And I did that not in one place. I mean, several places, a dozen places. And the average would be like that. And then we have a head of business agility or something like that, that is like responsible to help the organization to embrace agility and then solve those problems. But as I said, it's like they are outsourcing responsibility for the process. And the other day we were talking to discuss this. You said something that got me thinking, because I always had the idea that, well, we have the product champion, which is a lead engineer and also responsible for the product and the success of the product in the market. And then we have the line manager. That could be analogous to Scrum Master or what we call Agilist today, or an Agile coach maybe to be better, because as you said, the responsibility of a line manager is really to ask questions. He's not a person responsible for the process. Could you iterate a little bit in that and how we could? The idea is to pass some message to the audience so that they can understand that agility is not something that you do, it's not something that you buy or you outsource, but it's actually something that you are. So what do you think about that?
Okay, what I think about that is that we've gotten too hung up with here is the exact steps, probably because some people, especially people who don't understand the complexity of writing code, what they're trying to do instead is find some silver bullet that's going to solve their problem. So they read a book and say, do these steps. These steps are guaranteed to make stuff work. Well, those steps made something work well for somebody else. They solved somebody else's problem. But by copying processes, you are copying the solution to a different problem than you have. So at the beginning, like in the early 2000s, before there was so much adoption of Scrum, I saw some companies figure out, based on principles like yours, the one you described, figure out and do some amazing stuff. And then all of a sudden along came this textbook canned process, and people adopted that instead. And I stopped seeing creative solutions to my problem. And I started seeing people just try to copy processes and not succeed because they're not solving the problem at hand. That's true that they are interesting things you might consider, but a process is something that is constantly changing based on your context. And if you copy a process from somebody else, we've rarely seen that do very much good. It doesn't mean you don't understand the process and why they do it, but you need to understand how they developed that process and then develop one that meets your context. And they will not be some process out of a book. It'll be principles that you apply to your environment and say, okay, so we're seeing this kind of problem. Other people have solved it in this way or this way or this way. Which one of those ways might we try and see how it solves our problem? But it's not by having meetings and by not allowing people there and by doing, it's by putting together a context of here are 3 different ways we might solve this problem. We understand our problem. We're going to do some experimenting to see what helps us get past that problem. And we're going to keep looking at it and improving upon it until we've got that particular big set of problems under control, and then we'll go on to the next one. But if you don't look at what's my biggest problem and what are good ways to attack that problem, and how can we make sure that the things that we're doing are in fact improving the situation, and how can we make sure that we're not measuring how conformant we are with process, but let's make sure we measure how much the process is improving the way that we work and the results of our work. So it's not that process is bad. It's that canned processes are not the things to apply to your environment. It almost never works. I only just want one example. In the US, there was a concept of, there were problems in like operating rooms in hospitals. And so there was a book written about how to do a checklist before you started surgery. And the checklist said, check this and this and this and this, and have the doctors ask this question and have the nurses be able to do these things and stuff like that. And it was adopted, but only when the hospitals developed their own checklist. Here's what this hospital found useful. Here's what this hospital found useful. Here's how these guys did it. Here's how those guys did it. Let's try 3 or 4 things to see what works in our environment. Those were the successful ones with the checklist. The other ones, it was just a route thing. Nobody really understood why they were doing it, what good could come of it, how to deal with situations where you found issues on the checklist. And they didn't ever develop the improved surgical outcomes that the hospitals that didn't copy the process, that said, this concept is good. Going through a checklist before you start surgery is good. I mean, aircraft pilots use it all the time. So
Right.
checklists are good. But how do you
And
do
a lot of those, yeah.
Before there was Agile, way back before 2000, the lean movement in the manufacturing world was decades old.
Mm-hmm.
And it almost always failed because people saw, oh, Toyota is very successful. At least they used to be. It was very successful. They're going to put us out of business. They're so good. We better do what they do. We better copy what they do. And so people copied their solutions to their problems in their context. And when they applied those same practices, they didn't work.
Didn't work.
And the successful, quote, lean organizations that we've seen around the world don't copy Toyota. They don't use the Toyota way. They use the Scania way. They use the way that their own people, Southwest way it used to be, the way their own people, their own leadership and the own responsible people have developed themselves based on their problem, their resources, their constraints, and it worked for them. But it's a style of thinking. It's not a set of practices. Now, there are technical practices, as you mentioned earlier, that were embodied in extreme programming. There are technical aspects to the still evolving cloud architecture and all of those things. Those two, just adopting them is not enough. They're critical elements.
Yeah.
Let's go back just like to
go ahead.
Yes, sorry, just to mention one thing. Sometimes people make Henry Knieber guilty for having created the concept of squads, right? The Spotify model that everybody is copying that. And what I have seen is I don't even like to use the term squad, because in essence, for me, that's a team in the first place. And people think that, oh, let's create a squad and we will be agile. And that's a total misconcept, I think.
Yeah, but remember, in Sweden, squad was a very specific term that was used for groups in the army. And that's where it came from. And it was a commonly used translation of team in Swedish. And so they thought that that would work because it gave a better idea of what a squad was to the people who happened to be there. It's not the word squad that matters. It's how do people work together to solve a problem. So let's get back to engineering again, because these things that we're talking about, you rarely find in engineering teams and engineering groups that are doing engineering even today. They would be insulted by some of our practices, and they wouldn't care if you use the word squad or team or whatever, group, you name it. Here's how we work together. Here's the size of the number of people that are needed to solve this kind of problem. And engineers use their training and their understanding of the domain that they're solving a problem to bring their intelligence to bear on that problem. So they have a way to approach things, but the much more important thing for them is to understand what is the problem that needs to be solved. What
Right.
are the resources that we have amongst us and available to bring to bear on it? What is the best approach we can take to make sure that we solve the important things first and then the next things? And good engineers in all kinds of fields do very well and have done very well for decades, thinking about how do we approach and tackle problems, and instead of thinking about how do we have somebody list up the jobs to be done so that we can take one and get it done as effectively. They do not allow somebody who doesn't understand engineering design the solution to their problem. I'm telling you, when I did a control system, that we would die before we allow a non-engineer to come in and tell us how to solve a control system problem. I mean,
I remember from the first workshop when I met you in 2008 in Buenos Aires. Very strong message coming from you and Tom about you don't tell an engineer what to do.
No. you don't. You tell them what the problem is and what the constraints are. And the constraints could be time, the constraints could be resources, the constraints could be, whatever happens. But when you get an emergency and a bunch of people are thrown at that emergency, you remember the miners that were buried underground in Chile? There was an amazing engineering team that got thrown at that. But interestingly enough, the head of all control mines were very senior engineers. And they approached the entire problem as an engineering problem. And number one, they did 3 different approaches. They didn't know which one would work, so they did 3. Can we do that in software? Oh, no, it might be too expensive. Okay, and everything about the approach that they took was very solidly based in the way that engineers approach and solve today's problems, emergency problems, urgent problems. And they thought carefully about how they were going to go about stuff, but they did it rapidly. And if you take problems that have to have smart people come in and solve them well, then typically you're going to see an engineering team come in. You're not going to see a software team come in and have somebody figure out the solution and give it to them. There's not time. And you've got smart people. Why not use their brains?
Yeah. Let me connect with a couple of thoughts we got here in the comments. One of them is from Frederico Jack. He's saying they don't tell us the full value story for devs because they don't want someone to argue his great ideas.
To what?
And to argue against the great ideas. Maybe I can try to.
Are they worried about the developer having a great ideas, or somebody else has a great idea that they don't, so they want?
Yeah, the second option. Because one of the things that I have seen is also they have a product department and a development department, and there is a wall between them.
Why?
And so,
let's just stop.
Good question.
Stop
that's
right
a good
there.
question.
Stop right there. You don't have that wall in engineering environments.
Yeah. But I have seen a lot of those in software environments. What would you tell to those companies?
Okay.
Where they still separate
done in software? Why are not the software engineers designing the solution?
That's.
I mean, that's what I would ask. If you have a problem that's going to be solved in software, then you need software experts to design the solution. Yeah. If somebody thinks that they have a solution, that's why we do rapid delivery and figure out what kind of feedback we get, because you know what? Their solution is probably not right.
But you know what they're doing? They get business analysts and UI UX designers to design solutions, and then they hand off to the software engineers to build. And
who's responsible for the success of the results?
That's a good question.
Nobody,
usually the product
right?
manager.
Nobody.
Yeah, in this case.
The UX designers aren't going to be there doing the implementation, so something's wrong.
There's a very effective concept for failure. It's called push.
Right.
You push someone else to do something, and then if it doesn't work, it's their fault for not doing it right. Push doesn't work. The whole essence of Lean, the whole essence of successful Agile is pull, don't push. That's the essential thinking concept. You don't push work. You don't push ideas. You offer them, you pull, give them a context in which they would have a chance of working. You try them. And if they work, you invest more in it. If they don't work, you try a different idea. Pull means you say, here's a problem. Here are the things that we can do, that we can't do, that we can do with the resources we have. Here's the value of solving this problem. Figure out how to solve it. Now, what skills have to be there? Well, today, certainly software skills are needed. Architecture, testing, all the rest of it.
Design skills are needed.
But design skills are needed as well. Knowledge of the business and the constraints of the business, the opportunities, the timeframes, the economic context. All of those skills are needed in order to put together a good solution to this problem, which is pulling the work from the group.
And you put a wall between them?
The team is the group of all of the people who are contributing to the successful solution of that problem. It's not 7 plus or minus 2. 7 plus or minus 2 might be a sub-team, or it might be more than the team you need. The idea is not that the team is sacred. The idea is that the solution is the target. So pull, don't push. That was the essence of the whole Lean movement for decades. It still is. And it is the essence of the organizations that succeed with Agile thinking.
So what I want to know is, where did we get these people who design solutions and then throw them over some wall to software? Where do we get the concept that this was a good idea? I never worked with that concept in all of the years. And remember, 30 plus years of programming before I actually ran into Agile. And I never worked with a business analyst, never understood the concept of somebody telling the team what to do, never got into my head that it was okay for somebody who wasn't a software engineer to design the solution to the problem. And that as a software engineer, I did what I was told. Never ran into the idea that this was a good way of doing things. So then all of a sudden we get this thing called Agile, and all of a sudden we've got these crazy people running around, figuring out what people should do and telling them what to do. And I think, how can this possibly work?
Yeah.
Because that's not a problem-solving approach.
Well, it started in the 80s and 90s.
True.
In the 80s and 90s, instead of software being something that experts did to solve problems that they understood, it became something that got scaled.
Right, because of
it got expensive.
Personal computing.
And when it got expensive, all of a sudden people that have no idea about software started managing it. And the management from the mid-'80s to the end of the '90s became so ineffective that a bunch of people developed this thing called extreme programming, and it helped a lot, at least after the developers got a hold of the problem. But still, the whole idea was that in order to make things efficient, they would subdivide the work and have the analysts and the designers do each their part of it and hand it off to the next, so that each one could be utilized for maximum effectiveness in order to get things done as efficiently as possible. Well, it turned out that this was not efficient at all. As you noticed, way back in the 80s, it would take 2-3 years before somebody's idea got analyzed, got approved, got designed, got approved, got architected, got approved, got coded,
The entire waterfall process.
got tested,
Got
and
fixed.
they always had to go back because it was never right what was handed to them. And after it was tested, they tried to deploy it, and it never worked. So they had to go back and fix it some more. And then they released it 3 years later, and it was obsolete.
If it ever was going to be.
So it took more than 3 years to get ready, and then
When year 2000 rolled around and we started doing our very earliest classes with value stream maps, we saw almost nobody that had a release cycle of less than a year. 1 or 2 years was typical.
Wow. I've seen
that was typical
back,
in the late 90s.
Yeah, I remember not far from, 7 years ago, I saw organizations delivering software every 6 months. And the interesting thing is that they didn't have any of the good practice to help them keep them safe when they deploy.
Yes.
And then because when they deployed, they had a lot of problems, they tried to augment the release cycle. But because they augment the release cycle, everybody from the business wanted their feature to be in that next cycle. We should cause a snowball effect, because next cycle will throw a bunch of more problems.
It just keeps getting worse.
Yeah.
So the concept of long releases was very common, because it was, well, you wouldn't want to release anything with any kind of defect, would you? So we had massive big bang releases, and everybody knows a big bang release changes so many things that they don't work. We finally figured that out. And we also started, to me, the best part about Agile is that it developed techniques, good business, good process, good technical techniques for allowing small releases safely. Whether they're testing releases, continuous delivery releases, you name it, the more rapid you can deliver, the more unlikely you are to make a major problem in the software, because you have a small change which you have protected with various types of some mechanism to make sure you can't make disastrous mistakes, and you do it a lot so you get much better at it. And the techniques we have developed for rapid, safe delivery of software and very rapid feedback from the results of that software, to me, that's the biggest change that happened in the last 20 years. If you want to call that Agile, then that's what we should be doing.
Right.
If you want to call having somebody tell software developers what to do Agile, then I don't want any part of it.
Right. So I am with you. I personally, I was able to keep my knife sharp in terms of coding skills, and I'm very happy with that, because if there's one thing that I wouldn't like myself to become, is a theoretical guy, like somebody that teaches something that don't know how to do anymore. That's not me, right? But I'd like to share a few comments from the audience. We have interesting comments and questions here. But before that, if you allow me just a quick share, I would like to share a quick story, because we were saying about separating the responsibility for the product from the development team and things like that. In 2017, I was in a small organization, about 60 people, but they used to be leaders on their market, on their segment in Brazil. They developed software for security monitoring and alarms and things like that. And they had about 800 customers all over the country, so they were leaders. And they were doing that with a software that they have developed 10 years before. Like, it was a 10 years legacy code already in 2017. But the leader, the CEO of that organization, was a very smart, very, very inspiring leader. And back in 2011, when he realized that the cloud computing would change things, he understood that he would have to move to the cloud. So he went ahead, before the time came, I think before the entire movement was hot, he developed a new generation of their systems. I don't know exactly how he had done that, but he outsourced some things. Like the design was done by a design studio and somebody else developed, and then it was a completely failure. So I was there 5 years later. What happened is that they couldn't handle more than 15 new customers or 15 customers, concurrent customers at the system at a given time, because these guys would hate the solution. They would go to the competitors, or they would go back to the old software.
Yeah.
And they were suffering with that, and I was there to help them transform their culture. They didn't have anything about Agile. They didn't have, it was really, old style of management. And I remember once when I was in the bathroom and I heard somebody from the customer success area complaining about the software. And then I thought, whoa, how can someone that is responsible to guarantee the success of the solution complain about the solution? Then I brought this guy to talk to me and understand he would think about the solution. And he told me a lot of things. Oh, you do this differently and differently. And then I asked, why don't you told this to the guys when they developed the solution? And then he said, I was not allowed to do that. And then they had completely separated, like the product guys were one department, development guys were another, support were another, customer success were even another. So, and then I asked and then that year we've run Roshin Kanri to do the strategic planning for the organization. And one of the strategic objectives was to solve that problem. We didn't know how, but the goal was to solve that problem. And then I asked the CEO permission to run a continuous engineering workshop. And that was the first time that I applied what I have learned with you. And for me, the results were incredible, because I got 35 people from all over the organization, put them together, separate them in 3 teams. Every team was a full team, like they had a designer, architect, and somebody from all the departments, from the financial, from the development, from the support areas, and so on. So we have done design sprints of 45 minutes, doing concurrent engineering on paper, like drawing wireframes. And at each interval, we would share and steal ideas from each other and improve the design. So by the end of the day, we had 3 awesome designs. So we went home. The next day, we got together again, and then we merged the designs. So we got what we had, the best parts of each, we merged. And then we designed, I would say, a medium fidelity drawings, and then we went to test that with real customers. We got out of the building, went to the customers and asked them, what do you think about this? Would this be better than what you have today? And he said, absolutely. And then we came back, and from that we improved the design a little bit more, and then we extracted the backlog and so on. And we wrote everything with tests automated from scratch. And in 4 months, we had developed and had solved a problem that was lasting for 5 years. And that company doubled their revenue in 2 years. They were sold and they acquired a bunch more customers. And for me, was incredible, because what I did there was an experiment. Totally an experiment, because I had never done that before. I've read in your book several times, and if something went wrong, I would call you.
And I never heard.
Just kidding. But that was awesome.
Yeah, what you're trying to do is let the smart people who write the code and the various people from different departments get together in the same room, improve upon ideas, then start delivering and get feedback from customers and constantly improve it. And you can go pretty fast if you're structured not to have all of these pauses and handoffs and stuff like that. And when you have this rapid feedback from customers, you are way more likely to get something that they like, because as soon as they don't like it, they're going to let you know. And the changing of it is not going to be a particularly big problem. And I will tell you this, every single person here, if your company is competing against a company that works like that, you will fail. They will win. Guaranteed. You can't.
That's a good advice.
You cannot compete against a company that takes their smart engineers, puts them together in a room with designers and architects and those sorts of people, gets them out in the field with maybe even some cell phone, gets feedback from customers, does rapid delivery, takes the feedback into account, modifies it to make the customers happy. If that's what you're competing against and you're not doing that, you are not going to win. You can't.
Yeah.
And
Exactly.
you don't. Now, maybe the companies that you're competing against aren't doing that yet. But when they figure out how to do that, you're toast unless you do too.
Yeah. So I think that's a good advice. I will try to capture
But
some
does
of
that
these
mean something in Portuguese? You're toast?
Sorry?
You are toast. That means you're dead.
Yeah. You are
I just realized I
tá-
used an idiom that probably didn't
Okay.
translate very well.
We would say você tá ferrado. You are like you are screwed, basically.
Yeah,
We
screwed,
can
right?
say
But we say toast.
that.
Think of it as
So,
birds, right?
Let me read a few questions here before we wrap up. Lavoisier has one interesting question. What would be productivity in software development?
Can we please talk about that?
Please,
Just hold
let's
off
do
on the
that.
questions.
Mhm.
Productivity is not anything like how much code or how many features you produce in a unit of time. Because in software, the more stuff, the more code in the code base, the more features you implement, the worse it is. Because you have a bigger ball of mud to keep organized. The more stuff you can do with the least amount of software, the better you are. So there is no way that measuring amount of features or code produced by a team in a unit time is anything but measuring how bad they are, not how good they are, not how much work you churn out. It's not how much activity you have. It's the
So it's not
impact.
about how many story points per
Has
sprint.
nothing to do with that, because remember, when they're implemented, all they do is mess up your code base and give you more stuff to maintain. If they
Right.
haven't done something for your product, for your customer, and they're in your code base, they're bad. Okay, so
Right.
counting how much junk that you're able to put in your code base and calling it productivity is ridiculous in our world.
The problem
Right.
is in the question itself. Productivity means how much value has resulted from an input of some kind of investment. Well,
Right.
software development is useless. It has zero value. So software productivity is always zero. What has value is the use of the software in the marketplace, the sale
Right.
or the lease or the use of the software. That's where the
Right.
value is.
So we come back to
Yeah.
business value.
Absolutely. The only value that can go in the numerator of software is the value of the outcome.
Right.
Output is useless. No matter how many lines of code you have, it has no value. The value
or
comes,
negative value.
Yeah, even a negative value. The value comes not from the software, but from the whole team that worked together to conceive, design, deliver, test, operate, all of that. Without all of that, there is no value. So the
Right.
software does not have productivity. The whole product team has productivity.
And their
Right.
productivity can only be measured not on how many products that they design and put out, but on the impact of that product on the lives of the businesses of the people who buy them. So if you create a product that does massive good stuff for your customers, that's productivity. If you create a product that they're not particularly interested in, that's pretty low productivity. It doesn't matter how many story points or whatever that you do. So as you can never, okay, if you were an engineering department, would you measure productivity based on how many drawings the engineering department puts out? I mean, would you? That's ridiculous.
Probably not, yeah.
Would you measure the productivity based on how many students she has in her class? Not really. It's how much she was able to influence those students. It's how well those drawings were able to create a good product. So
Right.
the intermediate thing is a proxy for success, and it's a bad proxy. So one of the things that I heard from Jeff Bezos once, the Amazon guy, is he tries to keep Amazon young and always in day one, by not allowing proxy metrics.
Proxy metrics, and Don Harnison talks a lot about that too.
Right. Don't allow proxies. So software productivity is a proxy. Now, in a few very rare cases, it actually might be somewhat distantly aligned with the actual impact on the output, but not usually. And so productivity in general is a proxy metric.
I totally agree. I will have to watch this again afterwards to write an article about that because it's so rich. And one of the things we have another one. One of the things that I teach from my in my classes is the concept that I call code to value. So I tell developers not to code anything if they don't understand the value behind that. And if they decide to code, they have to measure after they deploy to check if the delivered value is matches the expected one. And if
they
it
say,
doesn't,
we're not allowed to do that, right?
Sometimes.
But then they're not allowed to be engineers.
Yeah, and then
they're not allowed to be responsible. And they basically, if they do a good job, they don't get any credit for it either, right?
Yeah, most of the times, yes. Especially when they have all these fences between them. But so, and then if they write the code, they have to measure to see if they deliver the expected value. If they don't, they should remove the code from the repository. Yeah. And that's another thing, because I've seen, we've done this, but the customer didn't like it, and they leave it there, like just improving the burden.
I mean, all it means is that you've got more stuff to create bugs and do errors in the future.
So another comment we have here from Everton. Everton said that did a research in his master's degree about how to detect wastes using data science. And he read, let me put it on. I've read a lot of papers, and some of them talked that thinking about wastes in terms of something that absorbs resources but doesn't create value doesn't fit the software development. Do you agree?
Absorbs resources, does create value.
Do you understand this statement?
I think it's a perfect fit.
The echo is back.
Yeah, I'm sorry, my headset ended the battery.
It's actually a perfect fit. If you accept that people's time is a resource, and that's a poor concept, but it does cost money. If you invest people's time in something that doesn't fit to create any value, of course that's a waste.
Right,
and see how it doesn't fit.
And complementing his idea, wasting software development is something that blocks the value flow.
What does that mean?
That is a focus on process. And it says that software development is all about process of taking what somebody tells you to do and delivering it quickly. But that's not what it's about. Delivering something that somebody asks you to do is total waste if it's not the right thing to do. And if there's no information that says this is the right thing to do. Okay. Software is not a step in the process of creating value. It is the process of creating value.
Let's take a look at professionals, lawyers, or, remember our structural engineers evaluating a house or buildings to decide if they're safe to go in. Would waste be something that slowed them down and had them be more careful about their evaluation of the building? Is waste something that the lawyer does and it doesn't and it blocks the flow of a judgment from him? Maybe it's better for the lawyer to take some time and make sure that they have the right concept. Maybe it's better for the structural engineers to evaluate stuff that they're just suspicious might be a problem. And I don't see how blocking the flow of getting stuff done has much to do with really good results that I am responsible for and proud of. Engineers have to make things safe. Their results of what they do last for decades. If a bridge collapsed, it's not because yesterday it was designed. It was designed 20 or 30 or 40 years ago.
Yeah.
But it can be a bad design.
Like
And
the
if
Tacoma
somebody
Bridge.
20 or 30 or 40 years ago took their time and said, we really need to overbuild these things here because they are the major structural components here. We really need to inspect this part of the building because it's on a pretty flimsy foundation rock down there. That's okay. Then they should be thinking about those things. And they should be thinking about how to do the thing they're responsible for in the best way, giving the most both short and long-term value to their customers.
Well, very nice. I think people are enjoying this because we have still have a few comments, and we have run out of time already. The conversation is really nice. Let me just read out loud here just a couple more
Sure.
comments, and then we can wrap up. One is again from Jack. One curious thing that happens that farmers developers that assume business positions tend to pass the solution of the problem and they don't let the actual developer think on it. I could say that this is true. Former developers that went to manager positions, they think that they still have to think and give to the developer the solution.
But that's because they're in an organizational structure that expects that kind of behavior of management.
Yeah.
A lot has to do with the culture of the company and how they expect managers to treat people working for them, that sort of thing. Again, if you walk out of the software world and into a engineering world, whether it's electrical engineering or structural engineering or even, building things, they probably don't work quite that way. And certainly the engineering departments I worked in didn't work that way. But it was an expectation on the part of management. My boss told me he keeps his senior engineers unassigned to projects so that they can come in and coach the younger engineers and solve the serious manufacturing problems when they arise. Because it's his senior engineers who are going to jump on the more difficult problems and train the younger engineers in to solve the more routine problems. And his job as a manager is to make sure that he has his best engineers available to throw at the most difficult problems and not have them tied up in more routine assignments. That's an attitude. That's a way of thinking about how you organize your work that was very acceptable in my company. Might not be acceptable in other companies. Mm-hmm. But in our company, that's the way managers were expected to behave.
Part of the message here is architecture matters. We've come to realize that very powerfully with the movement to the cloud. But we also have to remember that architecture is not just a technical issue, it's also an organizational issue. It's how we think together.
Yeah.
Not just how our components work together. Mm-hmm. And if we don't address the way we think together, all of us, that kind of practice of telling other people what to do based on our position is not going to get us very far.
And ultimately, I think that every technical decision is an economic decision. And I think that's how we should think about. Well, I don't know what to say. I am really happy to have had this opportunity with you because, I think most of my experience came through what I have learned with you. And I remember that when I started learning Lean software development 20 years ago and started implementing ideas, until up to, I think, 2006, 2007, I was still studying from your books and, reading articles and studying agility from the Agile Alliance library. And then I realized one thing. Wait, Lean comes from manufacturing. Lean comes from Toyota. So let me really understand how Lean was practiced in Toyota. and then I will have a better understanding. That's what I did. So I started reading a lot of books about Lean to really understand this, and things just started falling into place. I think I really love the principles and the values that come from this, and I'd like to thank you in the name of the guys that are watching us here. This will stay
Well,
on
thank you
our
for
YouTube.
inviting us.
Well, you have a place on my heart, so I will always have a pleasure to have you.
Right.
And
We're trying to be retired, but you have a place in our heart. That's why we said yes.
okay. Would you like to leave a last message to everyone here?
Think for yourself.
Pull, don't push. And don't let yourself be pushed.
And what to say to those newcomers, the agilists, the new ones that are being formed by, and without having food
Do you
on the
mean like
ground?
agile coaches?
Yes.
Agile coaching is not a career. Agile coaches' main job is to work themselves out of a job. When a company is moving from one environment to another, some coaching sometimes helps, but it should not be considered a permanent position. It should be considered a position that you are trying to not have around because the smart people don't need it. So if you think of agile coaching as a career, I recommend you look for a different one.
That's a hard one, huh? And what would you have to say to CEOs and C-level executives who are trying to scale agility and transform their organization?
Well, why are they doing it?
Probably because they're not happy with the results they have.
Well, okay, fine. If they want to change their results, they should focus on what results they want changed, how they communicate those results to the people who are going to do something to change them, and not tell the people that they have to do this agile transformation because that's going to solve their problem. How do they know? They need to present the problems that they need to address to the people who are going to tackle them, not measure how agile they are and hope that that gets them their problem solved, because it may or it may not.
Right. And I would add to that to get involved and get ownership for the thing. Don't outsource. Like, do the proper change management, right?
Yeah.
What I've seen is that CEOs hire me in some situations or other consultants, and they outsource everything. They think that they can go home, but they couldn't. Well, we have a lot of people here saying that the talk's really awesome. Thank you, Mary and
Great.
Tom. You guys are awesome.
Thanks.
And well, we need to end up, but this is really nice. Once again, thank you so much, Mary and Tom. I really appreciate the opportunity and for the value brought to us here. Right?
Thank you, Samuel.
Thank you.
It's been great.
We'll end the broadcast here.
Right. Bye-bye.
Thank you, guys. And I will finish in Portuguese. So, pessoal, não se esqueçam de se inscrever para a Semana do Agilista Raiz, onde a gente vai continuar. E amanhã tem a talk com a Mary e Tom Poppendieck, para vocês que estão aí no Instagram também. Mary e Tom Poppendieck amanhã. Perdão, Pat Reed amanhã, terça-feira. E semana que vem começa a Semana do Agilista Raiz. Ok? Valeu? Thank you.
Thank you.